Hello, this video is just to look at some of the changes that have been made in the latest version of the RUBE editor, which is going to be 1.2. And I just thought I might make a video like this every time there's a lot of changes or some things that could be better explained in a video rather than just reading the kind of boring release notes. So I'll start with the small things first so we can get most of those out of the way. And we'll finish up with the big things. The big things are the addition of 3 new joint types: weld joint, friction joint, and motor joint. So we'll get to those at the end of the video. So starting from the smaller things, you can now use the delete key to delete things as well as the backspace key. Let me start again. You can use the backspace key to delete things as well as the delete key. So you'll just have to take my word for it, but I'm hitting the backspace key here to delete those bodies. And the purpose of that is to make it a little bit more convenient for people using keyboards that don't have a dedicated delete key, such as some laptops and the smaller keyboards, those little aluminium flat keyboards that are made by Apple that some people tend to like for some reason. Okay, so next thing is we have an option here to save a copy of the file, and this is pretty much the same as save, except when you're done it doesn't change the name that you have for your current document. So you can just save a snapshot of something that you might like to keep for later without actually having to change the name of the document that you'd like to continue editing. Okay, so next thing is we can change the colors of the fixtures that are shown for static, kinematic and dynamic bodies here. So we're just using the standard Box2D green for static, blue for kinematic, and this kind of red for dynamic, and grey for sleeping has been the fixed default up to this point. So now we can just change them to something we like. So we could do dynamic bodies will be blue like that for example. I'll just put that back. Okay, and another thing we can do is we now have an option to well, I won't show you the details for this, but we have a new option to, or a couple of options here. When you're editing joints, it's quite common to set a limit or a value for the joint motors, but you forget to enable the joint motor, or you forget to enable the limits. So if you enable these 2 checkboxes here, every time you change the limit or motor values for a joint, it will automatically enable the relevant option for that joint, just so that you don't forget. Okay, next one. So there's been quite a lot of work done on the way images are loaded in the program, and you should see a lot of improvement for scenes that have a lot of small images or many of the same image. Those scenes should load a lot faster and render a lot faster and use less video memory to do so. Couple of things we can do with images now is when you drag and drop, or when you add an image to the screen, to the scene through this menu here, you can now set the initial opacity that will be used, and that's on the display tab of the options dialog. So the default image alpha is 0.5, or has been until now. You can set that to whatever you like to be the default. Another thing that's been added here is that you can choose to only show these image outlines in image edit mode, and what I mean by image outlines are these grey lines around each image, and currently they've been shown in every edit mode. So even when you're editing bodies or fixtures or something else, these outlines will be shown for images, and they kind of get in the way, especially when you have a lot of things, like in this case here we have a lot of images for the chain links and the wheels and so on. Even though I'm editing fixtures here, yeah, the image outlines are shown and they just kind of clutter things up a little bit. So we can unclutter things a little bit by selecting to only show those image outlines when we're actually editing images. So now if I go into edit image mode and back to fixtures mode, we'll see that the outlines only show up when I'm actually editing images. And we can also set the alpha, the opacity for these outlines. So you might want to just turn them off completely. You can set it to 0, or make them even more pronounced, you can set it to 1. If you set it to 0, obviously when you're selecting images you still need to be able to see the outline for what you're selecting. So of course when you actually mouse over an image in image edit mode, you'll be able to see the outline then. And if it's selected like that, you'll also be able to see the outlines in that case. We'll just put these back on. Okay, another handy feature that's been added is the ability to refresh images from disk without actually having to do undo and redo. Previously, if you wanted to change the image file on disk and then get it to show up in RUBE, you had to sort of reset the image file. But now all you need to do is Control-Shift-I to refresh images. So just as an example of that, what we can do here is we have these images, these boxes on the back of the truck, and I'll just open a player view for this, because in player views we can turn off fixtures so we can see these images a little bit clearer. Okay, so this is a player view, and I'm going to take this image that we're looking at for the box, and I'm going to just change that a little bit. Let's see, change the colors to something a little bit more red, and then I'll overwrite this file so it's changed on disk. Now back in RUBE we can do Control-Shift-I to load the changes from disk. So that's the manual way to do it, and you can also, in the options dialog, we have an option for doing that automatically. So if I check this checkbox here, it will automatically check every 3 seconds in this case to see if the file time on all the image files in the scene has been changed, and it will update that automatically. So I could oops, what's going on here? So let's put a label on this box, and now that we have the automatic image uploading checked, you can just overwrite this file again, and we'll see in a few seconds that it gets loaded into the program as well. So we can do that while we're running the scene even. So this is could be quite handy to work on things where the fixtures are going to be part of the image, or you want to have some kind of alpha blending to have images on top of each other in the right place and so on. So I'll just overwrite that, and we can see that we can play with the scene while the images reload. So that's quite handy. Another thing we can do with images is we can give them a color tint. This is one of the requests came up. So I'll select this image here, and we have a new property here, color tint. This display is a little bit funny here on this operating system I'm using. I might have to fix that. And we can give this truck a color tint of bright green, like that, and that color will be used as the color of the texture. And this is exported in the JSON file when you export the scene, so you can make use of that in your own app if you need to. Right, what else have we got? We have an option here to adjust the force that the mouse joint, the maximum force that the mouse joint has when you're dragging things around. So let's have a player view of this scene. This is a scene demonstrating all the joint types. And I'm just going to drag this body B here, and it's joined to the body A above it by two distance joints which have frequency and damping set so that they make the joint kind of soft. And I'll drag this joint way over here, and we'll find that we get to a point where the mouse joint doesn't have enough force to drag it any further. So it gets to about to the middle of the screen at the moment, and that's because the further we pull it away from the resting position, the more force the distance joint is applying to pull it back. And at a certain point those forces become equal, or rather the distance joint becomes stronger than the mouse joint and it can't go any further. So this actually came up in the Box2D forums a little while ago. Somebody was asking how they could dictate where that point would be when the mouse joint doesn't have any strength to keep pulling the distance joint away. So it's a bit of a finicky thing to adjust. You have to either adjust the mouse joint force or the distance joint force. So I thought it might be handy to have a setting like that. So for example, if we change this to half of the default value, so 600, now we should see we can only pull the body half as far. Like that. So now we can only drag it a quarter as far. This is mostly only interesting or useful for interactions between the mouse joint and other joints. In other cases, like this one here, when the mouse joint is the only joint that's acting on this body, it doesn't really make all that much difference. It just makes things a little bit softer. See, the joint is very soft here, and if I put it back to what it was before, it's a little bit more snappy. Okay, so onto the main part of this update. We now have support for 3 new joints, and they are weld joint, which is symbolized by this kind of wavy circle, and that's supposed to look like a spot weld. And I won't explain how to set these up because they're all these new joints are very similar to a simple revolute joint. So what they do is, for example, weld joint, this is a soft weld joint. You can set the frequency and damping for this as well, and it just pins the two bodies together at a point with a bit of a springy stretchiness about them. And the way that you add all these new joints is very similar to how all the existing joints are added. So you can use your existing knowledge if you already have been using RUBE for a while, or you can look in the help to see how things are done. We have also a friction joint, and a friction joint is symbolized by this sort of a hashed pattern. Hashed, yeah. and it's supposed to look like something's been scratching on a surface with lots of friction, so that's why it has that funny icon. And in this case we have this body B here is joined to the static ground body, and the anchor is a little bit off to one side and that means that when we drop something right on the middle of it like this, not such a good example, it tends to tip to one side because the anchor because the friction is being applied over on the left of it. So if you're not familiar with friction joints, this body also has 0 gravity scale as well. Friction joint just tries to prevent movement between two bodies, and you can adjust the maximum force that it has to do that and the maximum torque that it can apply as well. So that's a friction joint. And last one we have is a motor joint, and a motor joint tries to keep two bodies in the same place relative to each other. So we have a motor joint here, and the icon I've used for the motor joint is just 4 arrows signifying that it has some motive force in it to move things around. And this motor joint here is connected, body A is the ground body and body B is this dynamic body on the right, and the red dashed line in the middle indicates that these two anchor points are disjoint. They're not in the correct positions at the moment, but as soon as we start running the simulation, we'll see that the motor joint will pull the body B into that position, and if it's out of the correct rotation, it will rotate it to be the correct rotation as well. So this can be useful for, and I think it was actually first designed for things like where you have a floating platform and you might want to have your character walk across the platform, and the platform will sink down a little bit but it comes back to its original position. So this so that's a motor joint. And the only thing that's a little bit different about motor joints is that they don't use, if I go to the properties panel here, they don't use anchor B positions. It's hard coded. If you look in the Box2D source code, anchor B is not actually used anywhere in the source code. So in the interest of keeping all the joints similar in the editor, I've used the same keys so we can translate and rotate and so on in the same way as other joints, but you cannot change anchor B for motor joints. And to get a little bit more specific, if you look in the source code, you'll see that a motor joint has an angular offset and it also has a linear offset, and these two values define how the positions of body A and body B should be kept relative to each other. So angular offset is set down here. So for example, I could make this 90 degrees, and let's see what that gives us. So that will keep it at 90 degrees, or we could make it, actually 270 was what I was trying to get. Okay, so that's kind of like the platform I was saying about before. So it's this floating platform. So that's the angular offset. Now the linear offset is not showing here, but that is essentially this anchor A local position. So this is anchor A is the anchor position in body A, which is the ground body here, and this position 5, roughly 5, 5 is what we can see here, the green dashed line. So that's the offset from the ground body's position where the body B will be pulled towards. So hopefully that doesn't confuse anyone too much. Just remember that this anchor A is in fact the linear offset when you're working with motor joints. Okay, that brings us to the end of this video, and if you have any problems or questions or comments or whatever, just send me a mail or mention something in the forums. Okay, thanks for watching.